Hi, in this video we will talk about differential equations. Okay, so differential equation is in chapter 6 from your book. All right, so we will do some introduction first. So what is the differential equation? An equation that includes derivative is called the differential equation. For example, if you say, for example, dy over dx equals to x, right? So this is an equation because there is an equal to sign here. So I wrote dy over dx equals to x. Here there is a derivative on the left side. If the derivative can be on the left side or on the right side, but if the equation has derivative, then it is called differential equation. So this is called differential equation. Another differential equation you could write like y prime plus y equals to x. This is another differential equation. Let's say a double prime. So there is a second derivative, right? On the first differential equation there is a first derivative. On this equation there is a second derivative. Okay, so this is also differential equation. Okay, and then it could be y to the 4, that is the inside the parenthesis 4 means it is a fourth derivative. Okay, minus 16 equals to 0. So this is another differential equation. So what is the derivative, highest derivative used on the first equation? It is highest derivative is the first order derivative, right? So this is called the first order differential equation. On the second differential equation, the highest derivative is y double prime. So second order differential equation. And here it is the fourth order differential equation. Okay, so this is how we define the order of a differential equation. Next is solution of a differential equation is a function that satisfies the differential equation. Okay, so for example, let us say that y equals to e to the x. So is this a solution of the first differential equation? How do I check that? Is you plug in y equals to y equals to e to the x on the left side, and then see and find the derivative. Okay, and then if it satisfies the differential equation, then it is the solution. If it does not satisfy, meaning that if you don't get the left side and the right side equal, then it is not the solution. Okay, so we will try two equations. One equation we will try is y equals to e to the x and then see if satisfy. Another is I will try x square over 2 and then see if it satisfies. Okay, so let us check if it satisfies. So what I'm going to do is I'm plugging in, okay, to that equation. So you do d e to the x over dx equals to x. On the left side, what is the derivative of e to the x? It is e to the x itself, right? And then what is the right side? It is x. So is this always true? No, it is not always true, right? So that's why this equation, so the e to the x is not the solution because the left side and the right side are not equal. So the answer is no. Now let us plug in y equals to x square over 2 in the same equation and then see if it is the solution or not. So d over dx, so there is the function y is x square over 2. So what is the equals to x, right? In the right hand side we have equals to x there. On the left hand side I plug in, I replace y by x square over 2. Now then what do you get? Then you get, what is the derivative of x square over 2? This is derivative of x square is 2x over 2, right? You can add 1/2 and then 2x. Is you get x equals to x? Then it is yes, because x is equals to x. It is identity, right? You get the identity when you plug in the values of y. So this is the solution of differential equation, that differential equation. This is not the solution of that differential equation. So if you want to test whether a given function is a solution or not, what you do is you replace all y by the solution value, the value of y. Okay, and then if you get left side and the right side equal, then it is called solution of the differential equation. Otherwise it is not the solution of a differential equation. Okay, so we'll see more example later. So the next thing is order of a differential equation is the highest derivative used in the differential equation. We already discussed about that. So this has order 1, this has order 2, this has order 4, right? So order is the highest derivative used in the differential equation. Next is the general solution and the particular solution. Look at this. On this example, if you write y equals to x square over 2, this is a solution. Now if you write y equals to, let's say some constant like c x squared over 2, then that type of solution, okay, if that satisfies, then that type of solution is called the general solution. Okay, for example, let us see that. Suppose that you have a differential equation. Let us say dy over dx equals to y. Suppose this is a differential equation, and we want to check y equals to c times e to the x. Is this a solution here? I want to check that. Okay, so let me plug in that values. What do we get? If I plug in, I will get d over dx, y is c times e to the x. C is a constant, okay, equals to c times e to the x, right? So what is the left hand side derivative? C is a constant. Now what is left is d e to the x over dx, meaning the derivative of e to the x is also e to the x, equals to c times e to the x. Yes, right? So this is a solution. But if you replace c by 1 or 2 or 3, -1, -2, -3, or any values or 0, whatever values of c you pick, you get this as a solution. Okay, c equals to 1, 2, 3, any values of c is also the solution. So this is called the general solution that has a constant there. Okay, so y equals to c times e to the x is a general solution. General solution that satisfies for all values of c. Okay, now what is the particular solution? Particular solution is used, particular solution is found by plugging in certain values of c. Okay, but how do I find out that c value is? Another information will be given to you. So another information will be given to you, and based on that information we will find out the value of c. Okay, for example, the information may be given like dy over dx equals to y, and then they will give you like y at 0 equals to 2. If they give you like that, then you will use that y at 0 equals to 2 to find out c, and then you will get c equals to 2 in that case. We will do many examples of that type later. Okay, so just for now, general solution has c in it, a constant in it. Okay, but a particular solution will have the value of c replaced by a number obtained. That number will be obtained by using the initial conditions. Okay, by using some conditions there. All right, so let us see some examples. We will see the general solution, the particular solution, and other examples as well. Okay guys, so let us see one example here. It says verify that y equals to c times e to the negative 6x squared is the general solution of y prime equals to negative 12xy. Okay, here y equals to c is given, right? So it is a general solution, but we need to check if this is the general solution for this equation or not. Okay, and you want to find out the particular solution by using this condition as well. All right, so how do I first verify? You will plug in the value of y into the equation. So what I'm going to do is, first of all, I want to verify that. So what I'm going to do is I'm going to plug in that y here on the left side first. You get c times e to the negative 6x squared prime, that's the derivative, equals to negative 12 times x times y is just plug in that c times e to the negative 6x squared. Okay, do you get left side and right side equal? Let us find out the derivative. So c times, so you can pull out c outside and find the derivative of e to the negative 6x squared. Do you remember what is the formula for the derivative of e to the e to the u? E to the u derivative will be e to the u, okay, times u prime, right? That's what we are trying to use here. So c is constant, so I pull that out from the derivative. Now the derivative of e to the u, it is like a u, okay? So it will be e to the u negative 6x squared times u prime is how much of the derivative of the exponent? Negative 12x, right? Because 6 is constant, so x squared has derivative 2x. So negative 6 times 2x will be negative 12x. Equals to negative 12x c e to the negative 6x squared. So what do you get on the left side? Negative 12x c e to the negative 6x squared equals to negative 12x c e to the negative 6x squared. So it is the general solution, which is verified, right? Verified. Now we want to find out the particular solution using that value. Okay, so next, so we use that value, use the condition y0 equals to 4 in, we will use this in where? Y equals to c e to the negative 6x square, right? So what does it say? When x is 0, y is 4. That's what it is saying, right? When x is 0, y is 4. That means we plug in 4 for y and 0 for x. C times e to the negative 6 times 0 square. What do you get? That is just c, right? So what is the value of c? Therefore, c equals to 4. So what is the what is the particular solution on this initial condition then? Initial condition means that condition that gives for x equals to certain value. Here I got I got the condition like when x equals 0, y is 4. So it could be any other thing, right? So what is the particular solution then? Hence you got what? Y equals to, we got c is 4 and then e to the negative 6x square. So that is the particular solution for this equation, okay, with this initial condition. Okay, so that's how we find out the that's how we verify the solution, whether it is solution or not, and then find the particular solution from the general solution. Okay, let us do another example. It has find the particular solution of s double prime of t. You see that there is a double prime equals to negative 32, and then s0 equals to 80, s prime of 0 equals 64. I think we have done this type of problem before in the antiderivative. Okay, so what we need to do is we need to take the integral of that. Okay, so solution. So we have s double prime of t equals to negative 32. Right now, how do we need to find the particular solution. We need to first find the general solution for each of those, and then we will use the initial condition to find out the particular solution. Okay, so s double prime of t equals to negative 32. Now how do I find out st? Our goal is to find out st, right? So how do I do that? Is let us first integrate. If you integrate, what do you get? If you integrate you integrate there, right? So if you integrate, what do you get? S prime of t. That's the first integral. If you take one time, then you get one of the derivative will cancel out, right? Equals to, what is the integral of negative 32? It will be negative 32 t plus a constant c. Okay, now to find out that c, we will use this condition. S prime of 0 is 64. Using s prime of 0 equals to 64, you replace t by 0 and then s prime by 64, right? We get so 64 equals negative 32 times 0, t is 0 and s prime is 64, plus c. You get, therefore c equals to 64. We got c equals to 64 there. Okay, so hence, so thus we get what? Thus s prime of t is given as what? Negative 32 t plus 64. That's what we get. Okay, now but we need to find out, we need to solve this equation, meaning we need to solve for st. We need to find out what is the value of st. So we need to integrate again. Let's integrate again. If you integrate the left side, what do you get? You will get just st, right? And in the right side, what is the integral of negative 32t? Negative 32 times t square over 2, right? Plus 64t plus, again you can write d or c again, because I used c here, that's why I want to use different letter, constant letter. This is the constant of integration. It is like a c, but I wrote d because I used c already. You can still write c and then find out c again, that is perfectly fine. But if you do like this is also okay. Okay guys, so let us see how much you get there. So let us simplify that. You get s t is equals to negative 16t square plus 64t plus d. To find out the value of d, because the question says find the particular solution, right? We want to find out the value of d. How do I find out d? We use that condition, right? Use s at 0 equals to 80. So replace t by 0 and then st by 80. That's what it is saying, right? We get what? We get 80 equals to s at 0. 80 equals to negative 32, negative 16, and t square will be 0 square because we are replacing t by 0, right? It will be 0. 64 times 0 equals d. So we got d equals to 80. So what is the final answer? Hence, the particular solution, the final answer for the particular solution is, you get s of t is equals to negative 16 t square plus 64 t, and replace that d by 80. So that is the final answer. Okay guys, so this is how we find the particular solution, as well as we verify whether a solution, whether a function is a solution of the differential equation or not. Okay, basically to find out the particular solution, or to find out the general solution or particular solution, usually what we do, we integrate. Okay, we need to integrate that. All right guys, so let us see some more examples, which is continuing the examples we were doing. Okay, so this example says, determine if y equals to 2 sine x is a solution of y, the fourth derivative of y, and then 4, that means fourth derivative of y minus 16y equals to 0. Okay, so what we need to do is we need to find out the fourth derivative of y here. So we have y equals to 2 sine x, right? What is y prime? Is 2 cosine of x, right? What is y double prime? That is negative 2 sine x, because the derivative of cosine x is negative sine x. Y triple prime is negative 2 cosine of x, and y fourth derivative will be y triple prime, right? And y iv fourth derivative, or you can add iv, or just for equals to what? You get 2 sine x, right? So what do you get here then? So you get basically you get, so y fourth minus 16y equals to 0. So what do you get here? You get y fourth is 2 sine x minus 16 times 2 sine x equals to 0. Are they equal? 2 sine x minus 32 sine x equals to 0, right? So which is not equal, so it is no, so which is false, right? So this is not a solution. You see that? So this is not a solution of the given differential equation. All right, so let us see another example. Determine C if the solution, this is the solution given, okay? If the solution 2x square minus y square equals to C of the differential equation. This is the differential equation and the solution is given here, and you want to find out what is the value of C if the solution, if this solution passed through 3, 4, okay? So what we need to do is we need to set x equals to 3 and y equals to 4, and then find out C. Okay, how do you get that? You do 2 times 3 square minus 4 square equals to C. So you get C equals to 3 times 3 is 9 times 2 is 18 minus 16, right? So C equals to 2. So what is the particular solution here then? It will be 2x square minus y square equals to 2. That is the particular solution for this problem. Okay, so next example is find the general solution of dy over dx equals to 3x to the 8 minus 2x. So in this example we need to integrate on both sides, right? So let us integrate on both sides. What do you get on the left side? Y is equals to, so basically we are integrating in every terms, right? What do you get? So 3, what is the integral of x to the 8? X to the 9 over 9, right? And then minus 2, what is the integral of x? It is x square over 2, right? So and then plus C, don't forget that C there. So general solution always has C in it, right? Or a constant in it. So y equals to 1 over 3 x to the 9 minus x square plus C. That's the final answer. Okay, so how do you find the general solution of this one? We integrate on both sides. What do you get? Y is equals to, what is the integral of tangent square x? We don't know, so we need to change into secant square, right? So what we do is we know that secant square x minus tangent square x equals to 1. So what is tangent square x is secant square x minus 1, right? So we write integral secant square x minus 1 and then dx. So what is the integral of secant square? So it will be tangent x, right? Tangent x, the integral of secant square is tangent x because the derivative of tangent is secant square, minus the integral of x is sorry, 1 is x, and then but you need to write plus c as well. So y, hence y equals to what? Tangent x minus x plus c, which is the final answer, which is the general solution. It has c in it, right? So that's how we do the some of the very basic example of the differential equation, whether it is a solution or not, and finding the general solution of some simple equations. Okay guys, so the next thing we will do is, sometimes we cannot find out the solution of the exact solution, or it is hard to find out the solution of the differential equation. Okay, in that case there are techniques we use. We use the direction field. That's what we are going to talk in the next video. Okay, and also we use the Euler's method. Okay,